Hello and welcome to the fourth video of me talking about my calculator. This is also the first video where I have a microphone, so hopefully my voice is a bit more pleasant on the ears. The game that I'm talking about today is Tetris, which is my favorite game that I've coded. It runs really fast, the graphics look great, and it is actually fun to play on the calculator. So let's get started. You probably know how the game Tetris works, but just to summarize, there are 7 types of blocks, and one at a time, a random block will start falling from the top. The goal is to move and rotate the blocks so that they fill rows, and once a row is full, it disappears and all the blocks above it are shifted down. Over time, the blocks fall faster, and you get points for how many blocks you can place and how many rows you can fill. My version of the game works almost exactly the same. It has all 7 blocks, and one at a time, a block will fall down from the top. You can move them left and right, rotate them, and make them go down quickly. My point system is not the same as real Tetris. I don't actually know what the point system is in real Tetris, but I give you 4 points for every block that you place, and when you fill a row, I give you 40 points times the number of rows that you filled squared. So it's always better to fill more rows at once. And each time you get 500 points, the speed increases. It starts at 1, and the max speed is 5. Once you're at speed 5, it's really hard to keep placing blocks. So the game only lasts around 10 minutes if you play the whole thing. Those are all the rules. Now I'll show you how I coded it. So this game actually uses 2 programs. One is called Tetris, and one is called Z-Tetris. The Z denotes that it's a sub-program of the main one, and it starts with a Z so that it's alphabetically last in your list of programs. And when you run the main game, it starts immediately. First it draws the board, then the blocks start falling. And I will show you the code now. These are both by far the longest code that I've written for a game. The Tetris program is 232 lines and Z-Tetris is 152 lines. It takes a lot to manipulate these blocks and to move them and check everything, and so it's quite incredible how fast this game runs. Now, I actually wrote this code a while ago. I think it might have been a year ago, and I do not actually remember how all the code works because you cannot write comments in TI Basic. So I'm going to do the best I can to summarize the main points, and really the important thing is the theory behind how the game works. So first off, when I was coding this game, I looked at these blocks. Now I would notice that all the L's and these ones and this one, they could all fit in a 3x3 grid, and they have a center point of rotation. So I was thinking maybe I would be moving a 3x3 grid down and then checking the squares under it to see if it's going to hit anything. But the problem is that the super long block fits in a 4x4 and has a different center rotation point, and then the 2x2 square does fit in a 3x3 square, but it rotates about a different center. So I was really trying to think, how am I going to code this? And then I figured out the really key detail here is that these are all 4 blocks each. Every single shape is made out of 4 blocks. So the way that this game works on the calculator is that there are 4 individual blocks, and each time they move down and check under them to see if they're going to be hitting a block. And to rotate them, there's not actually one shape that's rotating. It's more of a block will shift down 1 and left 1 if it's rotating, and then another block will shift up 1 and right 2, and then another one will shift right. So the blocks really just move around a center block. So this is really the important insight you need if you're going to code this yourself, and this is what makes the game run really fast, is that there are 4 individual blocks moving, and each of them have their own coordinate points that are remembered and saved in the code, and so there's really not much calculation that has to be done to move the blocks down and rotate them. So to start off, obviously it does your regular stuff like clear the graph screen and set your coordinate system. Then it's gonna draw your game board. It's gonna generate a random block, and then this is another important point. So the game runs really fast because as you're moving the blocks down, not many things have to be checked. It's just, are you moving down, left, right, or up to rotate? But after the block hits the ground is when a lot of calculations have to be done. So it has to obviously check every single row to see if it's full and then eliminate the rows. But that's what makes this game so fast. These blocks can move left and right really quickly and they can shift down, but then the second it hits the ground, it does take a little bit for the next block to fall down because that is when all the calculations are being done. It's not checking anything about the score or the rows during the free fall of the block, only when it hits the ground, which is why the game runs very quickly. So there's this big list, and this is how many rows are in the game board. And they'll start at 0, and every time a block falls and then it lands with, one of the 4 squares in that row, it'll add how many squares are in that block in that row to this list. So every time that the block stops and it's going to generate a new block, it just checks to see if one of these numbers are at the max, which is 11. And if it's an 11, then it's going to start doing the stuff to delete the row and shift everything else down, but that's later. So there's a huge repeat loop for this game. It starts at line 55 and goes all the way down to the bottom. But in this repeat loop, I can't tell you everything that happens, but there are the 7 blocks, and first it's going to draw the block at the top and then put that block in the next square. And then each time it's going to check under every single one of those 4 blocks, and they all have their own coordinate points saved in these 8 variables, the x and the y of each block. And so it can just check under each of those every time it's moving if it's going to hit something below it. Next, it gets the key inputs, which are, pausing, stopping, moving left, moving right, and then rotating. Rotating is where the Z Tetris subprogram comes in, because it takes a lot of thought to rotate each block. So every time you rotate something, it checks what block is it, block number 1, block number 2. It checks what the current rotation point is, what is it rotated up, left, down, or right. And then it's gonna give these like vectors for each block for where it's gonna move next. And you only need to change the position of 3 blocks every time, since it's gonna rotate around a middle block. The one at the beginning is for a different part of code that is not relevant to the rotating. But all of these have to be hard programmed in, all these vectors for each block and then each rotation. If you're at this rotation and then you're going to move to the next one, it's going to have to do these movements with each block. And then at the bottom, it removes the pixels for the last blocks and then redraws all the blocks. And then another important thing is that these blocks are really, really fast to draw. That's another key feature, is that to draw the whole Tetris block, or the whole Tetris shape, it's only 4 lines of code, because each hollow square with the 8 pixels takes only 1 line of code. Point on, and then it's the type of point number 2. So drawing the block is actually very fast. That's why you can rotate the block and shift it left and shift it right very quickly, because it takes very little movements in the code for it to do that. The next important thing is how the game actually judges speed, because the program cannot actually speed up, but every time that your block is about to fall down, it checks 5 times if you're at speed 1. It checks 5 times if you're moving down or rotating. So you can see this block, I can move right 5 times before it actually drops down 1. If you look at just the speed down, it is actually slowing down when I'm making all these movements, because it has to keep calculating the next position. But it's really hard to notice. But once the speed turns to 5, you can only move right 1 or left 1 or rotate once before the next time the block shifts down. So the speed is not exactly speed, but it's how many times it's going to check if you're changing the block rotation or location before it moves down 1. And so after all that stuff happens, at the very end, it has all this code to change the score and delete lines. And so, it's going to check in L2 if there are any values that are equal to 11. And so then it's going to shift those rows down. And then it's also going to update the score down here. This is how it does the score. Obviously, you're going to get 4 points if you just place a block, but then you're also going to get 40 points times the number of rows that you have removed squared to incentivize getting more rows at once. This code is going to be on my website as usual, so you can download the code yourself, play the game, or you can use it as a reference if you're trying to make your own games. That's all that I have for this program. If you liked this video, please subscribe, and if you have not seen the hamster wheel video, please check out the hamster wheel video. Thank you for watching, and I'll see you next time.